Hello everyone, welcome back. Now let's explain another method in order to to find the crystal structure of rhodium. Now the first method, which is simple, assuming the crystal structure and find the density. But be careful, if you don't know how to accurately calculate, when I say accurately with the digits, you will not end up having close number to the density. Sometimes both of them will come close. Why? Because you will round up numbers. So sometimes it's confusing to decide based on density. But for example, if you can calculate everything at once without rounding up the numbers, you will get exactly the number, as I did. So I did all the calculation once without rounding numbers. So I got the number exactly close to the given density. But let's say you're like a student, like sometimes you don't know how to calculate all of these equations at once. You'll calculate them one by one, you're writing it down. So each time you do this calculation, you round up numbers. Density will not come close to this one, or maybe both of them will come close to this one. So how you decide there? So there is another way that we'll go to find this crystal structure. This time we will focusing on what? Finding n. We'll check finding n. Now n will be integer number. Why? Because if it is BCC, we'll expect to be 2. If it is FCC, we'll expect to be 4. If it's simple cubic, we'll expect to be 1. If it is hexagonal, we expect to be 6. So n will always come as an integer number. It's one of the good approaches here to find n. Why? Because the number, when you're finding it, let's say will be 1.999. You know that's equal to 2. There is nothing confusing there. Why? Because the number will come close to the integer numbers that we know. 1 for simple cubic, 2 for BCC, 4 for FCC, 6 for hexagonal. So let's see how we're dealing with this one. Still we need assumption. So let's say we'll start with BCC. Again, if BCC, we'll check for BCC. We'll check for BCC. We'll check for BCC. Now, the checking here, what we do, we know VC is equal to A cube. We know VC is A cube. And we know that A is equal to 4 root R. So I can write this one, 4 over root 3R. This is the volume. BCC. So we're going to find N to see if rhodium has BCC crystal structure. What will be the N? We know that this N must be 2. Remember, some students say, so why do you find N? We already know N. Yes, it's checking. So I am providing all the information. A, we know it. NA, we know it. VC, based on BCC, I'll calculate the density. I'm going to use the 12.41, the given density. So I'm going to calculate N to see, is it BCC? How do I know it's BCC? If N comes exactly to be 2. I know that it's BCC. So this calculation a bit. So I'm going to arrange N according, I will arrange the equation according to N. So in that case, we're going to use this equation. N will be equal to density VC Avogadro number over atomic weight. Well, let's write it down. N at the top we have density. Density, it's given 12.41. So 12.41 multiplied by, we have volume of the cube. Since we assume it's BCC, we want to check BCC, so we're going to use this one, 4 over 3 root 3, 4 over root 3. R, we know it. We're going to change it to also centimeter. 45 10 to power minus 7 is centimeter, and don't forget to cube it, then multiply by Avogadro number 6.022 10 to power 23, and at the bottom we have the atomic weight, which is 105.9, 105 or 102, 102, sorry, that's supposed to be 102. It's supposed to be 102. Here we have it, 102.9055. Now the units are okay. Yes, this is centimeter cube, this is gram centimeter cube, this is gram per mole, this is mole per atom. The result will be atom. Everything will cancel each other. It will come out as atom. So if we calculate this one, if we don't get close to 2, we know that this is not a BCC crystal structure. We already know it's not going to be BCC, but let's calculate to see how much it will be the atom mistake, sorry, takes a bit time. Root 3 multiplied by, I'm calculating directly, I don't have the result, apologize. And you can remember, I need you to calculate those things by yourself as well in order to see whether you will get the same answer or not. Going to be 2.17. 2.17. Remember, it's supposed to be integer number. 2.17 is not integer. So if you don't know it, we'll go for the other one. We'll check for base FCC. You will see what do I mean when it comes integer. So check for FCC here. Check for FCC. The same equation. We're just changing what? Volume. Why? Because the rest are the same. 12.41 multiplied by, we know that in FCC we have 2 root 2 R. R will be 0.1345 10 to power minus 7. So we're only changing the cube. The rest will be the same. Now somebody calculate the volume before it can be to see what do I mean when this n will be integer. Now I'll calculate this one, and if you don't get exact integer, we know that we have, exact integer will be so close, maybe 3.99 something. Okay, the result come out as 3.998. As I said, that this is what we call it a close enough to 4. So we say that we know that, and this is 4, and we already know that if FCC small n will be 4, so the crystal structure is FCC. Now this is a bit different than the previous one. Here we calculated n, and n must come as integer. It's close to integer. Look, 998, it's 4. Not like this, 2.17. Okay, let's say this is 2. No, it has to come, one of them will come as close as to the number that we know it. So for FCC, we know small n will be 4, so it will come as close to 4. If this one, for example, 1.9998, we know that it will be 2, or 2.001, something like this. So it will be as integer, close to the integer that we know it. This is another way that we can calculate a crystal structure by using density equation. Thanks for watching.